All right, in this video, we are going to talk about the following example. It says use a calculator to solve the following equation for theta on the interval from 0 to pi. All right, and it's cotangent of theta equals minus 4.2. So just like the other examples in this section, we are going to use one of the inverse trigonometric functions that we talked about to solve this. And we've only talked about inverse sine, inverse cosine, and inverse tan. Those are the three most common ones. But this equation involves cotangent, and we haven't talked about the inverse cotangent function yet. So what you want to do is use the fact that tangent is 1 over the cotangent, or vice versa. Cotangent's 1 over the tangent. And basically this relation says that they are reciprocals of each other, right? So if these two sides are equal to each other, then when I take their reciprocal, right, 1 over that, so 1 over the cotangent, that is going to be equal to tangent. So if I flip cotangent over, 1 over cotangent, it's going to be equal to tangent. And then if I have to flip the other side over as well to keep things balanced out. So basically we are looking, right, for where the tangent is equal to minus, or 1 divided by minus 4.2. And that will be the same place roughly where the cotangent is. Although in this problem we're going to see that there is a huge catch when doing that, okay? All right, so now I'm going to go ahead and solve this, and I'll show you the catch in a little bit here. So all right, so next then I am going to use the inverse tangent function. And take the inverse tangent of both sides. All right, and so what I've been doing when solving these, right, is referring back to the properties of the inverse functions, right? Going back to these slides here and looking at them and saying this property, the fact that tan inverse of tan x equals x for all x from minus pi over 2 to pi over 2, right, allows us to say that this left-hand side will just be equal to theta, okay? All right, so the huge catch in here is, if you go back and look at that slide, right, for tan inverse, it says this is true for x's that are in between minus pi over 2 and pi over 2. All right, so between minus pi over 2 and pi over 2. But if you look at the interval that they give us on this, it's from 0 to pi. Okay, so that does not match up with this interval right here. And so now there could be complications based on that. All of the previous problems that we've done, and we've done 3 examples before this one, all of those examples, the interval that they talked about in the problem matched up perfectly with the interval for which the property is true. However, this one does not, okay? It does not. And so when that happens, then that's an extra piece of complication that is added into the problem, okay? You would still go about it this way, but what you're going to have to do is you're going to have to double check as to whether or not the answer is in the correct range, okay? So let's keep going and work this. Now we're going to go to the calculator, right? And notice that they gave us this interval in radians, right? 0 to pi. So that means they want the answer to be in radians. So I need to double check that I'm in the radian mode. I am, right? So that's good. And now I want to do inverse tan of 1 divided by negative 4.2. Okay. And I get minus 2.337, right, to 4 decimal places. Okay. Okay, so now you might think that's the answer, right? But if you look at that, that answer can't possibly be correct, right? The reason is because they want the answer from 0 to pi, okay? So if they want the answer from 0 to pi, well, this is a negative number. It couldn't possibly be between 0 and pi, right, which is roughly 3.14159, right? So this is not in the correct thing. So if I go through and let's just take a look at this. Well, first, before I take a look at it, let me tell you what you need to do on here. What you need to do is, because this is not in 0 to pi, the way you fix it is by adding, in this case, is by adding pi to it. So the answer will be pi plus minus 0.2337. Okay? And so if we did that on the calculator, we're going to get pi plus minus 0.2337. All right, and so we're going to get 2.9079 to 4 decimal places. Okay, so that's how you would fix this answer. So let me explain why that fixes it. Okay, so we took the inverse tangent, right? If you take a look at the inverse tangent, we took the inverse tangent of a negative number. So if I go to that unit circle, right, that I talked about before, this is not necessarily a value on the unit circle. But remember, right, the unit circle, when I do inverse tangent, it is always going to give me an angle that is on the right side of the unit circle between minus pi over 2 to pi over 2. Right? If you notice, the tangents up here are positive, right? And the tangents down here are negative. Okay? If you look back at the problem, that's what we had. We were taking the inverse tangent of a negative number. Okay? And so we got this value, minus 0.2337, which is down here somewhere. So let me get this where I can draw on it. So the inverse tan is always going to give us an answer that's in between pi over 2 and minus pi over 2. And it gave us an answer down, I'm just going to draw it right here, down here. Let's say that's where it was, okay, that angle right here. So that's, and that's probably not accurate at all, but just to give you the idea what's going on here. So that's where our answer was. What the problem is asking for, though, right, is an answer that's up here, right, in the top part. And so what that means is that the answer, right, if you take this angle right here, and I didn't draw it very straight at all because it's hard to draw with my mouse, right? So imagine that's supposed to be a straight line. So imagine that's a perfect straight line, right? That's a perfect straight line. Then the value of the tangent for this angle from here to here would be 0.2337 as well. Okay, so if it's on a perfect straight line, which it's supposed to be. All right, now you might say, hey, well, how is that true, right? Well, if you look down in here, right, if you figure out where this point was, it'll have an x-coordinate, right, which will be a positive number, and it will have a y-coordinate, right, which is a negative number, so whatever it is, because it's positive and then negative over here. If I go 180 degrees, right, pi units this way from the angle, that point that I get is going to have the negative of the x, the opposite of whatever the x is here, right? And then the y coordinate is going to be a positive number as well. Okay, and so when I do the cotangent or tangent, it's going to have exactly the same tangent. Okay, and that's a little bit, maybe a little bit hard to see why that's so. The main thing is that the issue and this problem, it comes from the fact that they wanted the answer from 0 to pi, but that doesn't necessarily match the range, right, of the inverse tan, which is minus pi over 2 to pi over 2. And whenever you have that situation, you do have this possibility that you could run into that you would have to adjust. For tangent and cotangent, it's going to boil down to, on these particular problems, okay, it's going to boil down to adding pi to the answer. When I looked through the Newton problems, these were the only ones that I could see that had this issue in them. So I kind of want to exclude these from the Newton problems, but because they're not, this is our first attempt at this, and so this one is just naturally more complicated than the other ones that we did. But I don't see any way to exclude it, and I don't want to exclude the easier version. So that's the whole purpose of this video, is pretty much to tell you exactly about this issue. So if you run into it, you'll know how to deal with it. If you have any questions, don't hesitate to reach out and let me know. I'll be glad to help you.